So for this video, we are going to discuss the limits of trigonometric functions. Now, before we start with examples, we want to remember two important identities. First, the limit of sine of x over x as x approaches 0 is equal to 1. Now, it is important to remember that for this identity to hold, or to be equal to 1, the input of sine and the denominator should both approach 0. And for it to be equal to 1, they should be equal. So for example, it could be something like this. Limit of sine of 2x over 2x as x approaches 0 is equal to 1. As we can see, if we're going to plug in 0 to 2x, it becomes 0. So if the argument of sine and the denominators both go to 0 and they are equal, this limit is equal to 1. We also have the limit of 1 minus cosine of x over x as x approaches 0. So this is equal to 0. The argument of cosine should be equal to the denominator, and the arguments should also approach 0 as x approaches 0. Now, there are other variations of this identity. For example, you may encounter something like this. For example, this is the limit of sine of x plus 1 over x plus 1 as x approaches -1. So if we're going to plug in -1 to x plus 1, -1 plus 1 is equal to 0. So since the argument x plus 1 becomes 0 when you plug in the value of x that we are approaching, for this case, this is -1, this is equal to 1 as well. The important condition for this identity is that the argument of sine and the denominator should both become 0 if you're going to plug in the x value of interest. So let's apply it here. Okay, what if we're trying to find the limit of 4x over x as x approaches 0? So for the identity to hold, let's just rewrite the identity here. We have two conditions. First, the argument and the denominator should both approach 0. So this, when you plug in 0 here to 4x, it becomes 0. When you plug in 0 to x, it also becomes 0. So in that way, that condition is satisfied. Argument of sine and the denominator should become 0. That's the first condition. Check. The second condition is that the argument of sine and the denominator should be the same. Now, for this example, they're not the same. One is 4x, one is x. So we will manipulate the denominator or the expression by multiplying 4 over 4. Now, you're not really changing the expression because 4 over 4 is just equal to 1. So even if you multiply it by 4 over 4, it's still the same expression. So this is equal to the limit of sine of 4x, multiply 4 here, over 4x, as x approaches 0 times 4, the 4 that stayed on the numerator. So this whole thing is just equal to 1. So this is 1 times 4. Therefore, the limit is 4. The limit of sine of 4x over x as x approaches 0 is equal to 4. Now, let's move on. This. Now, before we move on with this, I want to clarify that the limit of sine of x, let's go back to the identity, as x approaches 0 is equal to 1. So is the limit of x over sine of x as x approaches 0 is equal to 1 as well. And this comes from the fact that the reciprocal of 1 is just 1. So even if you have the limit of the reciprocal of this, it's gonna yield the same answer, 1. Now, how do we need this here in the problem? So we have the limit of sine of 5x over sine of 2x as x approaches 0. So how do we do this? So let's rewrite the example. We have the limit of sine of 5x over sine of 2x as x approaches 0. Now, we can multiply this expression based on what we need. We want to make it sine of x over x. We want to make it of that form. So we need 5x in the denominator. We need 2x in the numerator. So this can be written as limit of sine of 5x times 1 over sine of 2x as x approaches 0. So what are you going to do? Multiply this by 5x over 5x and 2x over 2x. Now this can be brought here. This can be brought here. So let's write it. We have the limit of sine of 5x, excuse me, over 5x, which is this, times 2x. 2x times 1 is 2x over sine of 2x. And then we have remaining 5x over 2x as x approaches 0. Now, this will cancel this x's. So we are left with the limit of sine of 5x over 5x times 2x over sine of 2x times 5 over 2 as x approaches 0. Now, this is just equal to 1. The limit of this is equal to 1 times 1. So this is 1 times 1 as well, because 2x over sine of 2x, get the limit of that, that's also 1, times 5 over 2. Hence, the limit of sine of 5x over sine of 2x as x approaches 0 is equal to 5 over 2. This is the limit. Okay, now let's move on. Now, this is a one-sided limit. So how should we do this? Now, we have to analyze the situation first. So we have here the limit of 1 minus cosine of 7x plus tangent of 3x over sine of 5x as x approaches 0 from the left. Now, we may separate this through 1 minus 7x over sine of 5x plus tangent of 3x over sine of 5x. So let's write this. We have the limit of 1 minus cosine of 7x over sine of 5x as x approaches 0 from the left plus limit of tangent of 3x over sine of 5x as x approaches 0 from the left. Now, when it comes to this example, we have to be organized and we have to make sure that we remember specifically the identities. So just to recall, the limit of sine x over x as x approaches 0 is 1. So this is the first identity. We also have the limit of 1 minus cosine of x over x as x approaches 0 is equal to 0. So this is the difference of this. Now, how are we gonna apply these identities, or how are we going to utilize these identities? So here's the thing. We have already separated this. So let's multiply what we need. For the first piece, which is this, let's find the limit. So we have the limit of 1 minus cosine of 7x. And then let's separate sine there. So times 1 over sine of 5x as x approaches 0 from the left. And then let's just copy the right side. So we can actually multiply 7x over 7x to fill in 7x here, and 5x over 5x to fill in that 5x on top of sine of 5x. So this will be the limit of 1 minus cosine of 7x over 7x times, so this goes here, 5x over sine of 5x. This goes here. And then you have 7x over 5x. X here cancels. You're left with 7 over 5. Okay. We have already arranged this. Plus, okay, let's arrange the other side. Remember that tangent is sine over cosine. Tangent is sine over cosine. So whenever you have tangent of x, this is sine of x over cosine of x. So we can write tangent in terms of sines and cosine. So we have the limit of sine of 3x over cosine of 3x times 1 over sine of 5x. So we have written this separately as x approaches 0 from the left. Now, let's just copy the first piece. Okay, now we can write this to be plus the limit of sine of 3x, then let's leave out sine there. Let's decompose the cosine of 3x at the denominator. So times 1 over cosine of 3x times sine of 5x as x approaches 0 from the left. Now keep in mind that the only one needing intervention here are the sines. Because cosine of 3x is just cosine of 0. When you plug in 0, cosine of 0 is just 1. So we don't have a problem with cosines on the denominator. But we do have a problem with sines in the both in the numerator and the denominator. So multiply with what you need. You need 3x in the denominator. So 3x over 3x. You need 5x in the numerator. 5x over 5x. So you can write this as the limit of sine of 3x over 3x. This goes there. Times 1 over cosine of 3x. And then this 5x goes here. 5x times 1 is 5x. So 5x over sine of 5x. As x approaches 0 from the left. This cancels. So you have times 3/5. Then let's copy this. Now we are on the position that we can apply the identities smoothly and without hesitation. So this is just, so 1 minus cosine of 7x over 7x as x approaches 0. This is just 0. This is just 1 by the sign identity here. So we have 0 times 1 times 7 over 5, which is, of course, will just end up to be 0, plus this sine of 3x over 3x is 1. 1 over cosine of 3x is 1 over cosine of 0. Cosine of 0 is just 1. So this is times 1 again. And then we have sine of 5x over sine of 5x. That's also 1. And then times 3/5. This simplifies to 0 plus 3/5. So the limit here is just 3/5. So the limit of this is just 3 over 5. Okay, now let's move on. So let's have last two. Okay. Let's have number 4. We have the limit of 2z minus sine of 5z over z as z approaches 0. So how do we do this? We can separate this into two limits through this subtraction symbol. So this is the limit of 2z over z as z approaches 0 minus the limit of sine of 5z over z as z approaches 0. Now this cancels to just, the first term cancels to just 2. So you have the limit of 2 as z approaches 0 minus the limit of sine of 5z over z as z approaches 0. Now, the limit of the first term is just 2, but for the second term, we have to multiply 5 over 5 to make the denominator 5z. So this will be limit of sine of 5z over 5z as z approaches 0 times 5. This limit for the second term is just 1 times 5. Sine of 5z over 5z's limit is 1. So we have 2 minus 5. The limit is negative 3. Therefore, the limit of this expression is negative 3. Okay, now let's have the last one. We have the limit of the sine of 3x over x as x approaches 0. Now keep in mind that for the identity to hold, the argument of sine and the denominator should both approach 0. Let's see if this argument, sine 3x, approaches 0. So sine of 3x is sine of 0, which is equal to 0. So this satisfies the requirement for the identity. But we have a problem. The denominator is not the same as the argument. So we will multiply what we need. What we need is a sine of 3x at the denominator. So you can write this as the limit of sine of 3x over x as x approaches 0 times sine of 3x over sine of 3x. Now you will put this here. So this will be sine of 3x as well. And then put this here, sine of 3x over x. Now, this is just 1 because the argument and the denominators or the denominator is just the same. But we are lacking something here. We need to multiply this by 3 over 3 to achieve the identity as well. So we have here the limit of sine of 3x over sine of 3x as x approaches 0 times sine of 3x over 3x times 3. So this will be 1. The limit of this is 1. Then we have, this is also 1. The second one. And we also have 3. So the limit is just 3. Therefore, the limit of sine of 3x over x as x approaches 0 is equal to 3. That would be all for this video. Don't forget to like and subscribe and see the link for more information. See the link below for more information regarding uh, tutoring services. Thank you. Bye.